Imagine a massive artificial island built in the middle of the sea with luxurious homes, hotels, and roads standing on it. But the most surprising part is that the main body of this enormous island is made from sand and rock. So how can such a huge structure support so much weight without simply sinking into the sea? That was exactly the challenge engineers faced while building Palm Jumeirah in Dubai. Dubai wanted to expand its coastline and create new residential areas closer to the water. But creating new land in the middle of the sea was far from simple. For many marine structures, engineers can use concrete piles or massive foundations to create stability. But for the land itself at Palm Jumeirah, sand and rock were the primary materials. And this is where the real engineering challenge began. Simply dumping Dubai's desert sand into the sea would not work. Desert sand particles are relatively smooth and rounded, so they do not lock together effectively underwater. Instead, suitable, rougher sand was dredged from the seabed. Huge dredging vessels collected sand from underwater and placed it precisely where the new land was being formed. Slowly, the outline of new land began to appear above the water. But at this stage, it was still soft and unstable. If massive buildings were constructed on wet, loose sand, their weight could cause the soil to shift and settle, threatening the stability of the structures. There was another major problem too: the waves. Powerful waves from the open sea could gradually erode the newly created sand formations. So, engineers first built a massive protective barrier around the island. The structure is called a breakwater. Its purpose was to weaken the force of incoming waves and keep the water inside the island relatively calm. Millions of tons of large rocks were used to construct this protective structure. The rocks were arranged in different layers so that powerful waves would not strike the inner sand formation directly. Instead of making the wall completely vertical, engineers designed it with a sloping shape. When waves hit the slope, they are pushed upward and lose much of their energy instead of crashing directly into a flat wall. The spaces between the rocks also play an important role. As water moves through these gaps, much of its energy is dissipated. But another problem remained. If water washed away the sand underneath the rocks, the entire protective structure could become unstable. To reduce this risk, special geotextile layers were placed on the seabed before the rocks were added. These materials allow water to move through while helping prevent soil particles from being carried away. Once the huge ring of rocks was completed, the inner part of the island became much better protected. But now came another difficult question. How do you create a massive, precise palm tree shape in the middle of the sea? Drawing a design on land is easy, but when you are surrounded by nothing but water, placing exactly the right amount of sand in exactly the right location requires extremely accurate positioning. Even a small mistake by a dredging vessel could alter the shape of the island. To solve this problem, engineers used advanced positioning systems and satellite-based guidance technology. The dredging vessels were equipped with computerized control systems containing the precise coordinates of the design. This allowed the crews to carefully control where the vessels were positioned and where the sand was deposited. Through one dredging operation after another, the basic shape of Palm Jumeirah gradually began to take form. From a distance, it might have looked like nothing more than piles of sand rising from the sea. But step by step, those sand formations became the trunk, branches, and surrounding areas of the giant palm-shaped island. Yet one major problem still had to be solved. Sand may look solid, but inside it can contain countless tiny spaces filled with air and water. For the island to support heavy buildings, the ground needed to become much denser and more stable. This is where vibro-compaction technology was used. Special vibrating equipment was driven deep into the ground to compact the sand layers. The vibrations caused the sand particles to move closer together while excess water was forced out. As the ground settled, additional sand could be added where necessary, followed by further compaction. This process was repeated across different sections of the island to increase the density and stability of the ground. In other words, the engineers did not literally turn sand into rock. Instead, they compressed the sand particles so tightly that the ground could provide the stability required for heavy structures. However, after the breakwater was completed, another issue appeared. The protective wall around the island could restrict the natural movement of seawater. If water remained trapped for too long, its quality could deteriorate. To prevent this, large openings were incorporated into parts of the breakwater to allow water to circulate. During high tide, fresh seawater could move into the lagoon, while during low tide, older water could flow back out. This allowed the lagoon to maintain a natural tidal exchange. Then came another important concern: earthquake. When wet, loose sand experiences strong shaking, a phenomenon known as soil liquefaction can occur. This can temporarily reduce the strength and stability of the ground. To reduce this risk, the soil was densified using different compaction techniques before construction. In certain areas, deep vibration methods were used, while heavy equipment could also apply powerful impacts to increase soil density where required. The goal was to reduce empty spaces within the ground and lock the sand particles into a more stable arrangement. Through these processes, an artificial island was gradually created that could eventually support roads, homes, hotels, and other structures. But even after Palm Jumeirah was completed, the engineers' work was not truly finished. Because the sea never stands still. Waves, currents, and wind constantly have the potential to move coastal sand. That is why the beaches and shoreline of an artificial island need continuous monitoring. When excessive erosion occurs, additional sand can be placed to restore the shape of the coastline. So, building Palm Jumeirah was not a one-time project. Maintaining it is an ongoing engineering challenge. Another major challenge for the future could be rising sea levels and increasingly powerful marine storms. Any artificial land built in the sea must continue adapting its protective systems as environmental conditions change. Palm Jumeirah is therefore more than just a luxurious part of Dubai. It demonstrates that with careful planning, dredging technology, ground compaction, and coastal engineering, it is possible to create new land in the middle of the sea. But perhaps the greatest lesson is that humans did not truly conquer the ocean. Instead, they studied its forces and learned how to work with them. As long as waves continue to rise, tides continue to move, and the ocean continues to change, the engineering effort required to protect this remarkable artificial island will continue as well. Palm Jumeirah proves that projects that seem impossible can become reality through science and engineering. But the battle with the sea is never completely over. If you enjoyed this video, leave a like and subscribe to the channel for more incredible engineering stories.